So here we have question 4. We're trying to find an equation of a plane passing through a point 1, negative 1, 1, and contains the line of intersection of two planes, x plus y minus z equals 2, and the second plane 2x minus y plus 3z equals 1. So what do we need to know? First, we need to know the equation of a plane in its generic formula, which is r minus r naught dotted with the normal vector, and this is all equal to 0. So n is our normal vector of the plane that we're trying to find. Our r naught is a point that it passes through, which we're given here. And our r is just a generic vector x, y, z. So the only thing we don't know is our normal vector. So I'm going to try drawing this out. So we have a plane, kind of like this. Maybe I could draw that a little bit better. And then we have another plane. I'll draw that in red. They have the same line of intersection. They are just angled differently. And we're trying to find, I'll do this one in blue, this blue plane right here with the same line of intersection. And I'm just drawing a general plane. Right? And we need this normal vector, which points directly up, perpendicular to the plane. So that is our n vector. So that's what we need. So how do we get that? So first, we're given two planes, and we can find their normal vectors by just taking their coefficients. So I'll call this first plane n1. So the normal vector of this first plane would be 1, 1, negative 1, taking the coefficients of them. So that would be this normal vector pointing kind of straight out. And n2 for the second plane would be 2, negative 1, and 3. So if we take the cross product of these two vectors, we get another vector that is perpendicular to both of them. But in this case, we also get a vector that is parallel to this line of intersection, which I will draw in green. That line of intersection is this green line right here. So taking the cross product of these two would give me a line that is parallel to that line of intersection. So let's go ahead and do that. So we got n1 cross n2, which is equal to, I'll do I, j, and k. So we got 1, 1, negative 1, 2, negative 1, 3. So pulling out our I component, we got 1, negative 1, negative 1, 3, minus j, which is 1, negative 1, 2, 3, plus k, 1, 1, 2, negative 1. So doing our cross product, we get 1 times 3, which is 3, negative 1 times negative 1, which is positive 1, but we're subtracting them. So we get 2i. Do the same thing for the j. We get 1 times 3 is 3, 2 times negative 1 is negative 2. But we have to subtract them, so 3 minus a negative 2 is a positive 5. But we have this negative here, so it's minus 5, j hat. And then for the k, we got negative 1 times 1, which is negative 1. 2 times 1, which is 2. Subtracting them, we get minus 3. And this is positive, so it stays minus 3 k hat. So our n1 cross n2 would be 2, negative 5, negative 3. So this is a vector that is parallel to this green line. But our equation says that we need a normal vector, which is perpendicular to the plane, not parallel. So how do we go ahead and find that out? First, let's try finding a point on this line of intersection, right? We already know a point on the plane. We're given that 1, negative 1, 1, so we got to keep that in mind. I accidentally drew that point there. So let's go ahead and try to find another point on the plane. So we're given two equations, x plus y minus z equals 2, plus y minus z equals 2, and 2x minus y plus 3z. 2x minus y plus 3z equals 1. So we're trying to find a point, or actually, yes, a point on the line of intersection where these two planes meet, which is the line of intersection. So if we let z equal 0, right, we can rewrite this as x plus y minus 0. We don't need to write that, equals 2. And then 2x minus y plus 3 times 0, which is 0, equals 1. So now we see that this positive y and this negative y will cancel. We get x plus 2x, which is equal to 3x, and then 2 plus 1, which is equal to 3. So we get that x is equal to 1. And if x equals 1, we're going to take this equation here. It's simpler. We got x, which is 1, plus y is equal to 2. So 1 plus y equals 2. What's y? We could subtract 1. We get y is equal to 1. So now we have a point, x which is 1, y which is 1, and z which we said is 0. So here's a point that is on the line of intersection. We can call this point right here, somewhere on that line. So remember that, keep in mind that the cross product of two vectors will give us a perpendicular vector, which is what we're going to need, this blue arrow up here. So how do we find another point on the plane, on the line of intersection? Well, we're going to let p equal to 1, negative 1, 1, right? We can call this point p, because 1, negative 1, 1 is another point on the plane. Call that right here. And q, which we just found, 1, 1, 0, which is that first right here. So if we find PQ, right? If we go back here, PQ would be this purple line. So how do we find PQ? Well, we subtract their components, Q minus P. So if we do Q minus P, 1 minus 1 is 0. 1 minus a negative 1 is 2. 0 minus 1 is a negative 1. So now we have this. So now we have a green and a purple as to what I drew. This purple line and this green line, well, they're parallel to each other. They're on each other, but they're still parallel. They're facing the same direction. So if we took the cross product of those, it would make sense that we get this normal vector, because the cross product of two vectors gives you a perpendicular vector, and this blue vector, this normal vector, is perpendicular to both the purple line and the green line. So we have this vector, and we have this vector. So let's try crossing them. I'll do this in black. If we cross them, so we said n, we didn't give it a name, so I'll just keep it the same. N cross 2, cross with PQ, right? We got A, I, J, K. So 2, negative 5, negative 3. Actually, if we write it the other way, it'll probably make more sense. We'll get a positive answer. So let's, because you cannot switch the cross. If you switch the cross products, you'll get a vector that is pointing down, but still perpendicular. So let's try doing PQ first. Cross with the N1 cross N2. We did that. We would get 0, 2, negative 1. And then we would get 2, negative 5, and negative 3. So our I component, pull that out, we get 2, negative 1, negative 5, negative 3, minus j hat, 0, negative 1, 2, negative 3, plus k hat, which is 0, 2, 2, negative 5. So now cross multiplying, 2 times negative 3, negative 6, negative 5 times negative 1 is a 5. Subtracting them, we get negative 11. Negative 3 times 0 is 0. 2 times negative 1 is negative 2. Subtracting those, we get a positive 2. But this is a negative right here. So we have a negative 2 j hat. For the k, 0 times negative 5 is 0. 2 times 2 is 4. Subtracting them, we get a negative 4. So negative 4 k hat. So now this will actually be our normal vector. So I'll rewrite that as negative 11, negative 2, negative 4. So now we have our normal vector, which we needed for our equation right here. We have a point on the plane, and we have a generic vector x, y, z. So let's rewrite this. R minus R naught dotted with our n vector equals 0. So replacing it, we get x, y, z, our generic vector, minus r naught, our point on the plane, which is given. That's our 1, negative 1, 1. 1, negative 1, 1. And all of that dotted with our normal vector, which we just found. Negative 11, negative 2, negative 4. This should all equal 0. So let's simplify this part. We get x minus 1, y plus 1, z minus 1. And we're dotting it with negative 11, negative 2, negative 4, which equals 0. So if we multiply them, we get negative 11, x minus 1, plus a negative 2, y plus 1, plus a negative 4, z minus 1. This all equals 0. So we distribute each term, negative 11x plus 11 minus 2y minus 2, negative 4z plus 4, it all equals 0. So we subtract 11, because we want to add to the other side, plus 2 and minus 4. So negative 11 plus 2 minus 4 should give you 13, which equals 13, or negative 13. So now we have negative 11x minus 2y minus 4z equals negative 13. Or if you wanted everything to be positive, we could multiply by negative 1 on both sides. So now we just have 11x plus 2y plus 4z equals 13. And that is our equation of the plane.